Hello everyone. Today we will discuss the class 11th chapter Organic Chemistry, some basic principles and techniques. Here the syllabus of this chapter. First is general introduction, classification and IUPAC nomenclature of organic compounds, electronic displacement in a covalent bond, inductive effect, electromagnetic effect, resonance and hyperconjugation, homolytic and heterolytic fission of a covalent bond, free radicals, carbocations, carbanion, electrophiles and nucleophiles, types of organic reaction. First of all, we discuss what is organic chemistry. Organic chemistry is a branch of chemistry that deals with the study of hydrocarbons and their derivatives. Next is the shape of carbon compounds. In organic or carbon compounds, S and P orbital are involved in hybridization. This leads to three types of hybridization, which are sp3 in alkane, that is tetrahedral in shape, sp2 and in alkene planar structure, sp in alkyne has linear molecule. Functional group. The functional group are atom or a group of atoms joined in a specific manner which determine the chemical properties of the organic compound. The examples are hydroxyl group, aldehyde group, carboxylic acid group, etc. Here is the example CH3CH2OH. Here OH is act as a functional group, and in this example NH2 is the functional group. Next is homologous series. Homologous series may be defined as a family of organic compounds having the same functional group, similar chemical properties, and the successive members differ from each other in molecular formula by CH2 units. The members of a homologous series can be represented by same general formula CnH2n plus 2. For example, if n is equal to 1, it becomes CH4, that is methane. N is equal to 2, become ethane. N is equal to 3, become propane. Characteristics of a homologous series are, first of all, each member of the series can be represented by a general formula. All the members of the series can be prepared by the same general methods. Physical properties change throughout the series in a regular way. Members of homologous series have similar chemical properties. Next is nomenclature of organic compounds. Common name. Organic compounds were named after the sources of origin. For example, urea was so named because it was obtained from the urine of mammals. Formic acid was also so named since it was extracted from red ant called Formica. Here is some compounds and their common names. The first compound is CH4, that is methane. Common name is methane. CH3, CH2, CH2, CH3. Common name is N-butane. You can see other compounds also with their common names. Next is IUPAC system. What is the full form of IUPAC? International Union of Pure and Applied Chemistry. According to IUPAC system, the name of the organic compounds contain three parts. First, word root, second suffix, third is prefix. Word root. Number 1, word root. It represents the number of carbon atom present in the principal chain, which is the longest possible chain of carbon atom. For the special words, meth. For meth is C1, eth C2, prop C3, but C4. Second is suffix. Suffix are the two types, primary suffix, secondary suffix. Primary suffix, it indicates the type of bond in the carbon atom. For example, primary suffix ane for C carbon-carbon bond, ene for the double bond, ine for the triple bond. Next is secondary suffix. It is used to represent the functional group. Prefix. Prefix is the part of IUPAC name which appear before the word root. Prefix are the two types. Number 1 is primary prefix. For example, primary prefix cyclo is used to differentiate cyclic compounds. Here is the example of cyclopropane. Here cyclo is the what? Primary prefix. Secondary prefix. Some functional groups are considered as substituent and denoted by secondary prefix. For example, substituted group and the secondary prefix. Substituted group is fluorine, and its secondary prefix will be fluoro. For Cl, chloro, Br, bromo, No, nitroso, NO2, nitro, CS3, methyl, OCS3, methoxy. Naming of compound containing functional groups. Number 1, functional groups. The longest chain of carbon atom containing the functional group is numbered in such a manner that the functional group is attached at the carbon atom possessing lowest possible number in the chain. In case of polyfunctional compounds, one of the functional group is selected as principal functional group and the compound is named on the basis. The choice of principal functional group is made on the basis of order of preference. The order of decreasing priority for the functional group is shown below. The most